Hello everyone. Today I am going to demonstrate you the fundamental basic law of electrical engineering, that is Ohm's law. As you know, it states that the current through any circuit element in a linear circuit is directly proportional to the voltage applying across it. That is, mathematically we say I is directly proportional to V, or in other words we can say I is equal to 1 by R into V. As you know, R is constant, which represents the resistance offered to the circuit element. The equation of a straight line, as you know, the equation of the straight line, that is y is equal to mx, with m representing the slope of the graph. So here m will be equal to R, that is equal to resistance. Practically, we will draw a graph between V and I, and with respect to the value of the voltage, the current will be drawn in such a way that V by R ratio will always remain constant. So practically, we will see how this V by R ratio will remain constant. Let us start the practical. Let us make the circuit. As you can see the circuit diagram of Ohm's law, you can see we have a variable voltage supply. Practically we have a voltage supply here. We can vary this voltage supply from 0 to 30 volts. Then we have an ammeter, so we have an ammeter here. Then we have some resistance, that's 10 ohm. Also we have a rheostat, so that is here. So the elements which we require, that is the voltage supply, that is here, ammeter, that is here, and then we have the resistance. So now we will connect the circuit. Let us make the circuit first. So as you can see, we have a voltage source, that is minus and plus. As you can see, the plus variable voltage source plus will go to the ammeter. So let us connect this plus to the ammeter. So I have connected plus to the ammeter. Then you can see the another connection of the ammeter will go to the resistance. So another connection of the ammeter will go to the rheostat, the resistance. You can see we have two connections here. Then you can see the another connection of the resistance, you can see, that is here, will go to the negative side. So by this way the circuit is complete. I have made the circuit. Now let us start the practical and we will draw the graph between V and I. This is the V axis voltage. You can see the Y axis is the voltage and the X axis is the current. So let us draw the graph. So what our aim is, as we have to see the linearity property, that the resistance should remain constant. So first of all we will see the scaling property. That means if we will multiply or divide something, the output should also be multiplied by the same factor. So first of all, you can see that the zero input is giving like the zero output. As you see, the voltage is zero, the current is also zero. That means zero input is giving like the zero output. That is the first fundamental thumb rule, that zero input should give us a zero output. Then afterwards we will see the scaling property. So I will give 2 volts first. You can see that means you can see I have given the 2 volts. You can see I have given the 2 volts, almost this is 2 volts, and current is 2.2 ampere. We will see if I will, now first I will put this. You can see I have given the 2 volts and the current is 0.2, so I will put a dot here. If I will
increase voltage from 2 to 4 volts,
same current should be, that is scaling property, current should be multiplied by the same factor. That means if I have given, you can see the 4 volts, you can see the current is 0.4 amps. That means same scaling factor has been multiplied and that is reflected on the current. You can see. So that is 0.4 amps. Similarly, if I will again, now you can see, if again I will add it by 2, that is 6 volts, same should be reflected there. You can see 0.2, it should be 0.6 amps. Similarly, if I will add it by 2, that is 8 volts, same should be reflected on the output scaling factor. Okay, I am saying that. You can see it is 8, this is also 8.8 amps. So you have seen the scaling, how the voltage, when I am adding the voltage, same multiplying factor is reflected on the output, that's on the current. Now if I will draw the tangent, you can see, if I will draw the tangent, if I will draw a tangent, you can see somewhere, and if I can draw it on any 0.8 or 6 or 4 volts. So as you know, the tan theta is perpendicular by base. So mathematically we will prove that it should remain linear. As you know, tan theta is perpendicular by base. Our perpendicular is here. We say that OA, say it is O. So our perpendicular, perpendicular is AB, that is AB divided by OB. So by this you have seen, by taking the tangent, you have seen tan theta is that is perpendicular of base, and if we see at any instant, we see that the resistance remains constant. As we have taken the resistance that is 10 ohm, if we will take any value, whether we will take 6, then we will draw a tangent that will be 6 by 0.6, that will come 10 ohm, or 4 divided by 0.4, that will come 10 ohm. That means this way we have proven that the resistance remains constant. So this is the main aim of this Ohm's law, that the resistance will remain constant. Another thing, we have to see how direction of the current. We say that this is a bidirectional device. That means current flows in both directions.
So to prove whether it is a bidirectional device, that the current should flow in both directions, positive direction as well as the negative direction. Right now you can see I have given positive and the negative connection. The current is flowing. You can see. Now I will interchange the terminals. I will give, I have given already on the positive negative. I will interchange it, and you can see the current will go in the another direction. You can see the current will go into the another direction. You can see the current is going in the another direction, negative direction. So this way we are proving that this is a bidirectional device. Now if I will interchange the connections on the ammeter, you can see that the current will flow in the positive direction. You can see. So by this way we are saying that this current flows. Also, if I will interchange the rheostat connections, you can see the current
Is flowing. That means this is a bidirectional device. Instead of this, if we have the diode is a unidirectional device. I will also prove it in the next experiment. If we change the this potential, you will see the current will flow in only one direction. Okay, thank you very much.